Yeah, maybe it has to be done by ink.
Yeah. Ying, do you have a record button?
Oh, I didn't. I was muted. I don't know how to turn on the recording for Google Meeting. You know what should it be? But I guess today actually we'll just briefly go through some current progress. I mean, there will be no presentation today.
Yeah. So yeah, I guess because there is no scheduled presentation, maybe we can skip the recording this time.
Yeah, but yeah, Chinko maybe I'll throw Chinko is still recording this one, so maybe ask from Chinko AI for recording. I don't know, but whatever. Today is not the we will not have like a formal presentation, but we will have some just discussion of current progress on each item. And
yeah, I think I found where we can start recording. I mean, you can, you see on the downside button, there's between the hands, there's 3 dots, and open that dots, and in the upper bound you can see the recording.
oh, it says I'm not allowed to record this video call.
I'm not allowed. I think you should be able to. I don't even know.
Whatever. Yeah, I guess so we can start with still like CPU scheduling, CPU overhead hiding. Lemming, do you want to start, or Byron, you want to start? I guess you two can have one to start first.
Lemming, do you want to go first?
Yeah, probably I can go first. So
Okay.
basically, yeah, let me share. Actually, yeah, I will share some inside profile. So this is like the inside profile I run. So basically, you can see this is one decode step. It's some like 9 milliseconds, and then this is another decode step, and then basically between each decode step, there is always a noticeable gap. So over the last week, I did very careful study on this gap. Basically, try to analyze every single kernel during this gap, and then.
Okay.
But now I have a much better understanding. So basically, there is some 1/3 of that is memory allocation, and another third is to organize the input for flash infer, and then another third is flash inference planning. So basically, this is the gap, and so so basically, the goal of our CPU scheduling over hiding is to totally remove this gap. So this will be 10 to 20% for like almost all workloads.
But that includes the CUDA launch time. I mean that you said the 20% that include the CUDA launch time. CUDA launch time. The green.
You can ignore this for now. We all can look at another trace. So yeah, so basically like our goal is to totally remove this, and so previously we have an overlap like version. It works for it uses multiple Python threads to do the overlapping. And now I'm working on launching multiple Python processes, so we can also utilize multiple cores, and then get rid of the Python interpreter log. And also, if we carefully schedule this one, um, like we can when the GPU is working on the previous batch, we can already use another stream to copy the input data for the next batch, and also try to launch CUDA graph for the next batch. Yeah, so it will totally remove this gap. Yeah, so that's a high level idea, and we are almost there. Just need to launch 2 processes and carefully like prepare the input data, and the transmission between these 2 processes don't need to be that fast. because we have plenty room to overlap that. So we just need to launch a new thread here to feed in, to copy in the input for the next batch, and then it should be all overlapped.
Is the behavior different for prefill? The overhead, is it longer or?
Yeah. For prefill, the overhead is longer. So you can see this is prefill, and this is a gap for prefill. You can see it's longer, but it also runs longer. So
Okay.
yeah. So basically, this will be also be hidden by this one, right? For example, this is the last decoder step, and during this decoder step, we will prepare the data for the next preview batch. I guess in most cases, yeah, it can be fully hidden, but because the preparation time for preview is sometimes longer, so there still can be cases that this cannot be fully hidden, but they will be very possible.
Sorry, what's the relationship between the upper bound and the lower bound? I mean, the upper there's purple, right, and the downer side is the green one. Now you see the green one isn't directly aligned with this purple one. What's the difference?
You can ignore all this. They are just
Okay.
different annotation.
Okay.
Yeah, we just look like green. Blue means high utilization, and this white means underutilized.
Okay.
Or GPU idle.
Okay.
Yeah. So yeah, you can see for every decode step there is something, and then with two processes, I think it's, yeah, I'm very confident we can get rid of all of them.
Okay.
Yeah. So this is and like I already verified a lot of things. For example, our scheduler loop works, and there is no race condition, and like all the code, all the code can be mostly be directly used. So a lot of verification has been done. We just need to launch two processes. Yeah, it's the final step. Oh yeah, so that's update from me.
Okay, and then we can move to Baron.
Okay.
Hello. Let me share my screen. Hello. Can you see my screen? Hey.
Yes.
Yeah.
Okay, so I'm gonna talk about the project I'm working on. So basically, we want to design a cache-aware data parallelism working for multiple nodes. So the current status of SGLang data parallelism only support naive routing, like round robin, and also in a single node. So we want to make it scalable to multi-node and also support fault tolerance. So there are 4 requirements. The first one is that because we want to leverage the good thing of SGLang, which is repeat cache. So we want to make sure, for example, right now, if you have 2 requests and 2 requests have very long share prefix, but the router is not aware of the prefix, so it just randomly sent to different worker. But our design want to make it be aware and to send to the same worker as much as possible. But there's another condition, which is load balancing, because we don't want to send all the requests with very long share prefix to the same node. We want to balance between different nodes. So to make sure no workers are overloaded or underloaded. And we also want to make sure that a worker can be removed and recovered without affecting the availability. For example, when you send some continuous request and a worker die, you don't want the router to die as well. You want it to retry and continuously serving. Yeah, and this one is more advanced, so I'll skip it for now. And let's look at the design here. So I break it down to multiple sections. The first one is the overall networking architecture, and then the user interface, and then how we manage the worker to make it fault tolerance, and then how we route the request. And then the last part, I might not cover it much today because this is more related to Kubernetes. Yeah, so let's dive into the the first section. So my current design is that, so on the right side is a SGLang instance, and we call it worker here. So each worker has a HTTP server and also has a registry. Here we have 4 workers, and we want to have a router, also have a HTTP server to forward the request to the worker. Yeah, and on the router, we store 2 states. The first one is the active worker list, which means the worker are still healthy, so we can forward to that worker. And the second one is the routing policy we can choose. So for example, we can choose round robin, and we can choose more advanced version of the router. And this one is the extensible point. So I make it very flexible and easy to extend.
Do we only have one router?
Right now,
What is the router down? What is the router crash?
sorry?
What is the router crash? Should we have multiple routers?
Yeah. So in that case, I think we want to leverage Kubernetes and
Okay.
to launch multiple routers. And if one crash, it will immediately switch to another one. It's like leader election. Yeah. Does that make sense?
Yeah.
Okay. And then, so the user interface, so a lot of them is the same as the SGLang server, because we want the SGLang front end to directly talk to them. So we have, and the assumption right now is that all the instances are having the same config. So for example, when we call get server arguments, we just need to return the first worker. We might need to handle like heterogeneous cases afterward, but I'm not considering for now. And also we support 2 new APIs for worker management. So we can add new worker and remove new worker. So essentially, for example, you start a new SGLang instance, and right now you don't want to turn down the router. You want to keep it running, and you want to add one new worker in the middle, so you can use this API and pass along the new worker URL. So it will make sure the new worker is added and the new request can be routed to the new worker. And same for remove worker. Yeah. Okay. So actually the worker management is more complicated because you need to consider the case that some worker just crash out of some reason. So we break it down to 2 scenarios. The first one is that we do periodic garbage collection. So every certain period, we do a check for the healthiness of the worker and remove the unhealthy one from the active worker list. And another is that if we want to add new worker, we can call the API to scale it up and down. And for these 2 scenarios, right now in non-Kubernetes case, we need to, so for this, we need router to do the checking. And for this, we need user to call the add worker or remove worker. But in the Kubernetes case, it will be offload to Kubernetes operator. So this 2 won't be executed by either router or the client. It will be much easier and less overhead for the router. Yeah. And okay, the request routing part. So here you can imagine HTTP server serve as like a proxy. So you send a request to the server, and then the server run a routing policy and select the best worker, and then forward to the worker, and then send all the way back. Yeah. And right now I'm working with Yichan to discuss more smart algorithm. Yeah. And but one big bottleneck here, because we have 2 levels of HTTP. So I'm thinking maybe for this two, we don't need HTTP because this is not user facing. Maybe we can use gRPC or other lower overhead stuff. Yeah.
Yeah. So this is very good. So I think for the internal communication, we think we should get rid of HTTP. And I also have a question. Which language will you use to implement the router?
Oh, right now I'm using Python.
I see.
Yeah. But maybe I'm thinking to move to maybe Go or C++. Maybe if we want to move the HTTP server also to C++, we can also implement this.
Yeah, so I think because right now I'm running some profiling, and I find even for some simple like JSON serialization, or some like high concurrency, Python is super slow.
Yes.
So so I think here we can probably try some like other faster language.
Yeah, makes sense.
Like,
yeah, that's also in my plan.
Start from the very beginning. So I think overall we plan to move our current HTTP server, the fast API one. I think we have a plan to get rid of Python on that.
Do you know if the overhead is from HTTP or more from the Python side?
I think it's probably more from the Python side.
Okay.
But I didn't do careful profiling, and I don't have too many prior experiences on this. For example, I just sent a big JSON, JSON like token IDs. That's only like for example, 200K tokens, so 200K integers. I send it dual echo,
Okay.
200K integers, do an echo, send and receive. It takes 300 milliseconds.
Okay, that's not very fast.
Yeah, that's very, very bad.
Yeah. Okay. And okay. So I'll move on to the last part.
So my comment on here is if we can get rid of Python on the whole code path from the router to the work API and get rid of all of them, it will be our direction to go.
I don't know if it's the problem of HTTP because when we use multiprocessor.q, is it can send the request in a faster way.
Yeah. So
like when we have a single node and a multi-machine, we can just do multiprocessor.q to send the request instead of HTTP. And when we have multi-node, we must use HTTP to call the endpoint. And I don't think it will cause a very high latency to do that in a single node case.
For multi-node, I think maybe we can use gRPC or some other protocol.
Yeah, but in single node, I think right now, multiprocess.q is fine.
Yeah, but on the user side, we still want to expose HTTP, right? I think Yinan is talking about here.
Yeah, right.
Yeah, so this part definitely shouldn't be HTTP, right?
Yeah.
And user part is still HTTP.
Yeah.
And we cannot use multi-processing.q because this is for multi-nodes. Like
Yeah. So my point is that for multi-node, we must optimize it. But like for single node and multi-machine, like we do DP, like in single node.
But the expected use case for this one is multiple nodes.
Yeah. I know. Okay.
Is there a case that in one node we use DP?
I think there is still a case, maybe like where like they have 72 GPU and we cannot just do one TP. Is that right?
Yeah, I think if that's the case, we can provide an option to use IPC here.
Yeah. So a better strategy is use the general IPC. But Python multiprocessing.q, that's also very slow. Although you didn't notice here, but in general, it's also very slow.
Okay, but maybe faster than HTTP, but still very slow.
Yeah, still like we so here we are design. So I think our principle is we should directly go to the correct solution.
Yeah.
HTTP or multiprocessing .q, they are all not correct solution. So we shouldn't discuss them.
I see.
So do we I heard Kubernetes, do we supporting different not on Kubernetes, like on premises,
On what?
like on-prem devices, like not have Kubernetes type of thing, like
Slurm or something like Slurm.
Yeah, like I have my own cluster, like
I'm not that familiar with Slurm.
Or
even
just bare metal. I have, for example, I have 4 machines.
For
I think 4
we
H100 machines, and then I have one leading server around the router.
Yeah, but I think we can definitely have another service that is handling the worker management. But that service needs to, I think that's possible. Basically, just like right now for Kubernetes, we use this Kubernetes service to handle the worker management. And we can make this as an abstraction and add the support for Star and others.
I see. So this works for cloud setting, right? Like in the data center, if using this.
Yeah.
Okay. For on-premises, like.
But even on-prem, at least for LinkedIn, we are on-prem, but we also use Kubernetes.
Yeah, I think embracing Kubernetes is a great technical choice as it is supported by AWS, GCP, and OCI. So I think this should be the top priority. Maybe with other options can consider later.
Yeah, exactly. So XI also use Kubernetes, so I think it's almost a standard.
I think our goal can be that we can create a SGLang operator project under SGLang org.
I see. So the other question, like in the router we discussed, from this diagram looks like we're not making router complex to have a certain knowledge like a Redis tree stuff. Right?
No, the complex thing is here, routing policy. So here you also can have other state, like you can have a global Redis tree, you can have other.
Okay, so this design, it is kind of extendable. You're saying?
Yeah, extendable.
Okay.
I'll show you guys the code later.
And for the question like Yin asked, for the HA high availability, if the router is more complex there, ideally in network world, we designed the state sync between A and B, right? So basically you have 1+1 or 1 1 high A high availability. So you need to sync all those state cross, so that one when it's gone, the other one will take over seamlessly, not just a code start from fresh and then lost everything.
I think ideally we should like write the router state into somewhere persistent, and then make sure that if a router die, the new router can take over.
Yeah, that's true. But in real engineering picture, for example, 1+1, you just send it to other one will send to you. Both can work at the same time. Maybe one router serves 50% of traffic, the other router serves other 50%. When both gone, long
I see.
Long is interrupted, but just the performance getting a little bit, right? If both 100% utilized, then you lose performance. You don't lose the functionality or something.
I see. Okay. Yeah, I think a lot of like high availability and like fault tolerance we can implement here. Like we can also maybe have a Redis service to offload the state.
Yeah. Cool. Yeah, thanks.
So I'll briefly talk about this. So maybe some of you are not that familiar with Kubernetes, but I'll try to explain. So essentially, in Kubernetes, we can write, we call it operator. And operator is the job is to interact with multiple, it has very high privilege. So it can create a pod, it can delete a pod, and it can also receive the event from the Kubernetes server. And the event has very rich information. For example, if a worker become unhealthy, there will be something like an accident event. So the Kubernetes operator will know. And for example, if we change we update the resource config and say we want to add more worker, it will also be an event. So let's consider the first scenario that if a worker die and there'll be an event. In that case, we can we don't need to do this part. Kubernetes will handle it for us. We just need to send a request to our router to say that, oh, remove that unhealthy worker. Okay. And for the second scenario, that we want to scale up or scale down. So in that case, the first thing the operator do is to say we want to scale up, is to create a new pod. So here it will be a new pod. And the second thing is that we send a add worker request to the router so that we can easily scale up. Yeah. And for concern, we can have multiple router here and use leader election pattern that only one router serve at a time. Yeah.
Or you can have both router working at the same time.
Yeah, that's also possible.
Yeah.
Okay. Any question?
For router design, how many endpoints you consider?
You mean route?
I mean user interface, the endpoint.
Oh, here.
Is flexible, right?
Oh.
Let's the endpoint I'm talking a little bit different. I'm consider like how many virtual IP, how many service endpoint I'm talking about, right?
Just one. Or why do we need more than one?
Let's say you're serving something have different model.
Okay.
One model one serves certain request,
okay.
Model two serves. That's what I mean. Like a virtual IP or something.
Okay, I see what you mean. So, this whole thing is a SGLang router. It's a okay. Let's give it a name. SGLang service. This whole thing is a service, and inside the Kubernetes cluster, there will be multiple services. But for each service, it will only serve one kind of model. So there will be multiple replicate of this, but with different model.
Oh, I see.
And the operator operate all of that at once.
Okay. So this diagram looks like the router just for one model, for example, right? Yeah.
Yeah.
Okay, cool.
So this will be a service, and there will be multiple replicate of this service.
And you can aggregate multiple model interface to one to the router block. Then this router block behind it had multiple clusters for different models, something like that. Yeah, I don't know. I'm just asking if you not consider. Okay, cool. Thanks.
Okay.
So I actually have a couple questions, Byron. So I think hi. So I think the first is like in terms of the overall design, have you like thought about just like borrowing concept from like a distributed key value store and things like that, like Cassandra? Because I think this is a very similar problems. Basically, like you're trying to like you have a prompt that comes in, you can see the prompts as keys, and then you have some KV cache and like in like the memories and the workers, and you can see those as values, and like the distributed like a NoSQL key value store have a lot of designs handling things like that. Like for example, like disaster or like fault recovery for the router.
Okay, I see. You mean like offload the local information to somewhere central? and then so router can also access the data there. Is that what you mean?
No, it's not. It's not using a key value store, but like it's like borrow the design idea from there, like how like for example, like if a router crash, like what the recovery process should be like. How do you balance the load? How do you partition the traffic and distribute your Redis cache into different workers? So it's almost like you want to range partition your prompts cache into different workers, so you can like efficiently route based on a range into workers. And all.
I think the problem is a little bit different because for here, the difficult thing is that the router needs to find some way to get the information of worker to make the decision, because it needs to know, at least like speculate the cache hit rate and make the right decision. I think it's very different from like the normal routing.
Those problems also happens in like a traditional distributed key value store, because like nodes comes up and down all the time, right? You add new nodes as your load goes up, and like each node could crash. And I think like traditionally I rather leverage something like an etcd or a zookeeper to keep track of this sort of metadata.
I see. Yeah, I think I can take a look, but I feel like having a very heavy dependency might not be good for us. So I would prefer like keep the thing minimal and efficient instead of like pulling a lot of like Hadoop related dependency or like zookeeper. Yeah.
I feel what Ziliang talked about, that the key value thing is it's a kind of a complicated routing policy for cache-aware dispatching.
Oh.
They're saying that you can split the key range into multiple buckets, and then if you split well, that each bucket have the being balanced, some kind of still balanced.
Oh, I see.
And then if you add node or delete node, you need to rebalance that bucket maybe.
Yeah. So like you have an initial like range partition, and then you can like dynamically adjust your range based on the load. But like that could be like too complicated for the thing that you're looking for, depending on like how lightweight you want to have this system. Yeah, I think I agree that like you probably don't want to have like a super heavy external dependency. If you're looking for something that's like relatively simpler than like a full-fledged key value.
Yeah, but okay. Yeah, I think for that, if that is just algorithm, I think it makes sense. We can have an implementation for that. Implementation of router using like key value store for that. Yeah. Okay.
Yeah, I think I just think that like if you want to worry about like crash recovery and things, like those things could be like quite tricky. So I just thinking like looking into how other systems, how mature systems are handling that, and just borrow ideas from that would be one way to to explore. I think my second question would be just like you have a routing policy, which is probably the most complex part here. I'm just curious if you have like a version of routing policy ready.
So I'm still discussing and like thinking about the policy, mostly discussing with each one. And I think my immediate goal is to establish the infra, and then I can work on the actual policy. Yeah.
Yeah, policy could be something that you can plug into the infra, and you can have multiple choices of policy. But then, yeah, but like cache-aware thing, that kind of thing is definitely something we need.
Yeah. I have some idea.
Yeah, I think it's good that like you make this pluggable, and like this could get like quite sophisticated over time.
Yes.
Yeah, I was just like wondering what's your first version of the policy.
Round robin.
But then like if you do round robin, how do how do you do cache aware?
No, I'm not doing cache aware anymore. I just make the infra work first.
Okay. Sure.
Okay. Quick question. How
Hi.
do we address the need for auto-scaling? Is the SGLang Kubernetes operator?
So I discussed with Kaishun yesterday. I think he's here. So
Okay.
we borrowed the idea from Ray Autoscale. So I think one way is that we can have a Prometheus to keep monitoring the GPU utilization or like T-flops. And if we monitor some worker is using very low, and then we can remove that. And if we monitor that, then are too full, and then we can scale up. I think that the key here is that how do we define the signal?
Okay.
Yeah.
So this is automatic, is it right?
Yes.
Okay, makes sense.
So we just need to make it a Kubernetes event, and it will scale up.
Okay, and when auto-scaling happened, I think maybe, yeah, the cache is changed. And how do you handle this situation?
Good. Yeah, good question. So you mean you add the new worker, so the cache, the global cache is changed.
Right.
Yeah, I think there are, okay, if we adopt the idea from Preble, then we need to sync the newly add worker, the tree there, back to the global tree. That's one way. And the second way, also naive way, is that we can ad hoc query all the worker, the state. For example, we have a request, and we query the worker to say to see what's the cache hit rate of this worker at this moment. I think this is a very complicated issue. We're still trying to figure out how to, even for like syncing the local state and global state, we're trying to think about a more efficient way to make it work.
Okay. And how do you plan to implement a cache aware? Maybe in the next release?
Yeah, good question. I have some idea with each one. I can talk about it with you offline. Yeah.
Okay.
Yeah. And yes.
Please include me in that talk if you have time. Yeah.
Okay. Yeah, and I think the key is that we want to minimize the communication, but still like make a good judgment of the private cache. Yeah. Okay. Okay. I will move on to the demo. So right now I have implemented the garbage collection, dynamic scaling, and round robin. So okay. So here, let's look at the code. So this is a router, and router. Oh, I have a base router, and if you want to write a random router, it's very easy. You just need to extend the calculate priority, and then do a random choice. And say if you want to write a round robin, right now your state is the index. You just need to like have a state, and then modify calculate priority, and say if you want to implement a more complicated one with a global registry, you can also extend this interface and then construct a global registry here. Yeah. So okay, so here I'll run an example. So okay. Hey, wait a second. Entire screen. Okay. So here, so in this pod, I'm running 4 SGLang instance. All are serving Llama, and here I can start a router, and right now I'm using 2 workers. Okay, and now run a few shot GSM 8K example. Okay, and at the beginning, it will like wait until all of them are healthy. So let's see. Okay, ready to serve. 8080. So it's sending to the router. Okay, so you can see the router is doing the job, and the worker is also doing the job. Okay, and if we crash one worker, then it will keep the request will keep running because it will retry, so nothing will break. It can still finish. Yeah, and you can also add one more worker. Things will keep running.
Okay. So right now this is just the one roving worker. Yeah, I mean router, right?
Yes.
Okay.
Yeah, that's the basic demo. Okay. Any question? I will try to merge the PR. Maybe I'll try to finish it today or tomorrow. I need to write a test.
I have a question.
Hi.
Yeah. So I think probably, let's say if one worker is gone,
yeah,
is it designed or in the future will include scope that there's a seamless transfer for this work stop to the other work? Basically, say,
it's doing that now. So
are you saying you're sharing all those radix information? No, information
right
for
now I'm
using
using round robin.
No, I'm not talking about simple switch over. I'm saying, for example, worker one has his set of KV caches, right?
Yeah. So
and the worker B doesn't have worker A's KV caches, right? I'm saying we probably can consider that. Say if one worker has his data structure somewhere in the other worker, so this worker you take down from management, you want to change, upgrade, or just naturally gone, then the other worker will be, the service have no interrupt, right? Basically, because your KV cache exists in at least one other places.
I think you're talking about for like stateful router, it needs to handle the fault tolerance of the state.
It's actually, this is more than that, right? This is actually, there is a redundancy between workers even. Like you have one worker, you have your backup worker. And that backup worker also have his primary role. It all has his information backed up by the other worker.
What is backup worker?
Backup worker, like A has a functional primary for A's subset of KV doing his work, but there's worker B do B's primary set of KV, but B somehow has a KV of A's. And A have KV of C, C have KV of D, something like that, right? So like one worker is gone, there's no problem at all.
I don't quite understand.
Like you send a long request. Let's say you want to do non-sequence request. Let's say A in the middle, A is doing that, A is gone.
Okay.
And then B can continue with that. That's what I mean.
You mean A, B are worker?
Yeah. But with router's coordination, of course.
Say that again.
Hi, do you mean both A and B are computing or doing inference for the same request?
You can consider, for the single request, you can consider that way. But the B is not idle just to take over A when A is gone. B is also has B's request, and this other router, the other worker is backup B. If B is gone, the other worker take over. this is my, let me change the way how to describe this. So let's say A is a set of KV cache for the handling of his A's primary request, right? In the meantime, B also have B's set of KV for B's primary request. But B somehow also have partial or full replica of A's KV, so that even A is gone.
I think this thing, at least at SGLang, the KV will just be local. It won't be shared across worker.
Yeah, I understand that. I'm talking about system design, not just for this. I'm talking about is that Lian maybe can comment. Is that required because let's say in current one, right? One work is gone, the part of KV for that worker is gone, literally is gone. Doesn't matter how to design router, that KV is gone because assuming the router doesn't save all the KV for each worker, that KV information is lost. Is that right assessment? I need to rebuild. Like say send the worker offline, it's gone offline. You send that request to the new worker. New worker has to rebuild everything for those cases, right?
Hi, we cannot hear you clearly. Maybe the microphone has gone out.
Oh, okay. Sorry for that.
Yeah, maybe we can take the discussion offline, but I think this is still a good demo. And Chen Yang asked, we are almost about the time. So are there any other items we want to
I guess we want Shuo to present the results for double sparsity because that PR has been merged.
Yeah, maybe sure can.
Yeah, you can just like 5 minutes to tell people that we achieved through it.
Oh, okay. I would like to just share the screen. Okay, can you see the screen now?
Yeah.
Yeah, the PR now is merged, and we just implement the double sparsity and merge it into SGLang, and we now support the GQA and MHA models like Llama 2 and Llama 3. And you can just run the model with double sparsity with this command enable double sparsity, and you can denote the heavy channel num and heavy token num, and it's important to prepare the channel config. You can directly get the channel config from the double sparse repo like this. And you can process and get prepare the channel config for your own model by running this file group channel config, and this file can automatically generate the channel config file for your own model, and the preliminary result shows that in the long context setting, the MHA model with double sparsity can achieve be 3 times faster than the original 3 times faster than the original Triton implementation, and 50% speed up with the flash infer implementation. And in the GQA model, there's nearly 2 to 3 times speed up than the original Triton implementation, and 20% speed up in the 20% faster than the flash infer implementation. And there's still some minor things like we are going to add the 1 bit label cache, and we will speed up the top K gathering process, because the top K gathering process, we are still using the torch top K, and it is really slow. And we are going to improve this top K by with a better kernel. Yeah, and we are also there are people talking about the DeepSeek model, and maybe we'll support DeepSeek model too. And another part is the CUDA graph part. It's not supported by it's not compatible with CUDA graph for now, and we are going to support CUDA graph with double sparsity. Yeah, and that's all I want to say.
Cool, cool. And you have a blog post draft, and then we'll release it some days later, right? And then the blog post will tell people more detail about how to use the feature and what you can expect from the feature in a more organized way.
Yeah.
Cool, cool. This is impressive.
Yeah, thanks.
Quick question: why the preview latency will reduce?
This is because it's written by Triton. Actually, Yami and I just have talked about this problem, have discussed this problem, and we think we should use the flash infer to do the prefilling and use the double sparsity to do the decoding. And actually, we can split the prefilling stage and the decoding stage. We use different implementation.
Can we?
Okay, makes sense.
Can we also, like, if we use chunk prefill for the long context prefill, can we also apply the sparsity, double sparsity for the chunk for prefill stage, so that we can also accelerate the prefill?
Actually, in the prefilling stage, we cannot save computation from the chunk prefill by using double sparsity. And the main point of double sparsity is to reduce the KV cache access, the total KV cache access, and the chunk prefill is more compute bounded. And if you reduce the KV cache access, I think it won't bring much speed up for the prefilling stage. Yeah.
Well, isn't the computation also reduced? Computation complexity, because you don't need to do the full computation for. The number of matmos actually reduced, isn't it?
Yeah. Actually, I think it works. I think it might work, but I'm not sure whether it can help us to speed up. I think the total flops is reduced by if we apply double sparsity, but we need some empirical evaluation and the accuracy evaluation, because for now the prefill stage is only the prefill stage. The extra operation for prefill stage is just initialize the label cache, and if we apply the sparse pattern to the prefill stage, maybe we need to check whether it will cause degradation in the performance. Yeah.
We also need to see if for prefill, like you're actually union the sparsity from multiple tokens.
Yeah.
Okay.
So yeah, that's great. I have a question. Do you have like accuracy kind of evaluation? Like, I know the paper has, but do you run like a long sequence, like a mathematical testing to see? Interesting to see if any concern at all. Just in that front. Yeah.
I didn't test the accuracy. I only had a really simple accuracy test in the CI part. Okay. But I didn't test the accuracy with SGLang implementation. But the algorithm is exactly the same as the double sparsity repo here. So if you want to check the accuracy, maybe you can use double sparsity, SGLang with double sparsity, and you can use this repo. You can just run. You can just test the accuracy with this easy commands. Yeah.
Did you run with the double sparsity option on? What's the accuracy it gives you for the test in CI? Does it deliver the same accuracy as the before?
Yeah. It's but I only test the MMLU test, and MMLU is not long enough.
Right.
Because
we don't have a long one in CI.
Yeah.
Okay.
We didn't test the long. For example, if we want to test long bench, maybe yes, I will update this repo. This repo is still is too old now, because we add more supports for more models and more benchmarks. and we also add the quest for comparison, and we can see how it is compared with quest. The for now is kind of state of the art, but we are better than them. Yeah, and we will update these 2 repos. I will add a new PR and I will update the double sparsity repo. Yeah.
Cool. I think that's the main. We are at the end of the meeting. And if we don't have more questions, we can end now. We can adjourn.
Yeah. Thanks everyone.
Cool. Thank you very much.
Thank you.
Bye.